Hello, everyone. Welcome to how Millennium Bcp leverages Radius to empower developer and operator collaboration. I'm Nuno Guedes. I work at, Millennium Bcp, and I'm the head of public cloud, and with me I have...
I am Jonathan Smith. I'm the head of product management for the Azure Open Source Incubations team at Microsoft, and honored to be on stage with my friend and colleague, Nuno.
So first of all, show of hands. Are you familiar with Radius besides the network protocol?
Oh, good.
Nice, nice.
That's good. That's a start. We'll increase that number over the next 30 minutes.
Do you want to share a bit about what this is?
Sure. So we'll do a couple of things here. I'll start off and give some basic context about what Radius is, some demos of how it works, and then Nuno will walk us through some of the cool work he's done at MBCP to adopt Radius as part of their internal developer platform, including getting workloads to production on Radius starting in last December. So here we go with some context then. So as I mentioned, I'm in the Azure Open Source Incubations team at Microsoft, and we've donated several projects to CNCF. Today we're going to focus, as we said, on Radius, but hopefully you'll have a chance to take a look at some of the other projects that are listed here. Dapper and Kada, there's a lot of folks that I talked to at KubeCon that are familiar with those. They're already graduated CNCF projects. There's newer projects I won't touch on here too much, but just take a look at Copacetic, you see it in the lower left corner, and Drosy, two new super interesting projects. Like everything else on the list here, they are available freely on GitHub under the Apache 2.0 license. So if you get a chance, check them out. So in the context of Radius, Nuno and I will talk mostly about Radius features that help platform engineers like his team build IDPs that better serve their developer and operator customers. And I get to work with a lot of platform engineers, and they've taught me a ton about like the challenges they face and the platforms that they're building. And the way different open source technologies help accelerate that product development. And I think this graphic from Canoe does a great job sort of laying out a canonical reference architecture, showing a lot of the common elements in an IDP and a lot of the open source technologies that serve those platforms. And Nuno and I found common ground around an important concept and technology that we felt was missing in this landscape, and that's the notion of an application model or an application platform. And that gap matters because developers sort of live and breathe applications. It's what they design and build and support. It's what they reason about day to day. But in the world of distributed systems and cloud native technologies, it's gotten increasingly difficult to reason about an application as an entity, and even in a lot of cases agree on what an application is. And that ambiguity, in addition to all the other challenges around cloud native development, just adds to the cognitive load that developers struggle with, and it's exactly that load that the IDPs are designed and built to address. So, we felt that was an important gap to fill. And so platform engineers will have an open source project to draw from, just like they draw from so many other technologies on this slide. And one that allows them to add an application model to their IDP, so developers have a more application-centric kind of experience, and that's where Radius comes in. So Radius you can think of at the highest level as a cloud-native application platform. It allows you to define an application one time and then deploy it across on-premise, AWS, and Azure. You can use it standalone or with its companion technology, Dapper, which I mentioned earlier. But more importantly, what we're seeing most early adopters of Radius do is integrate it as Nuno and team are doing into their existing internal developer platform so they can offer that application model and enable those kind of application-centric scenarios. And we've worked with a lot of platform engineering teams over the last several months, and the feedback we're getting is really consistent. So our strategy from the beginning with Radius was for it to be a CNCF project, open source, and cloud agnostic. And the feedback that we get from platform engineering teams is total alignment there, like that's table stakes pretty much for every team we talk to. And then there's a few other killer sort of baseline features that platform engineering teams have kind of have brought us along about that we weren't as focused on. One of those is GitOps integration. Flux is the first GitOps integration we have, particularly for Nuno's team. It was a priority. Argo will be coming soon after. And then the second big feature that platform engineering teams educated us about was the requirement for Radius to be extensible at the resource level. So the ability to produce custom application resource types that allow a platform engineering team to expose resources in exactly the way their developers need to use them. So if it's a cloud storage resource, for example, the ability for a developer to just ask for a particular type of storage and say, I need small, medium, or large, instead of lots of detailed configuration. So that level of customization is really critical as well. And there's 4 ways you can think about how Radius might help your application teams and your internal developer platform efforts. One is that Radius improves enterprise application team collaboration. Part of that is by enabling developers to really focus on their app and a lot less concern with infrastructure configuration and deployment. Now, at the same time, Radius offers a feature to operators called infrastructure recipes that allows operators to, in advance, define exactly how infrastructure will be defined if an app is deployed on premise or if it's deployed on AWS or on Azure. They define that up front, and then developers get very much kind of a self-serve access to those infrastructure resources, and we'll see a demo of that in a second. Then the application graph is also a feature that helps teams collaborate, and it's super powerful feature. Every time you deploy a Radius application, it creates a graph that shows every aspect of the application. So every container, database, cache, front end, back end, and how they're connected. So it makes it trivial for everybody in the team, SREs, developers, architects, operators, to know exactly what's been deployed into production. And then lastly, it's cloud neutral, as I said before, so you have a consistent experience deploying across on-premise, AWS, and Azure, and integration with your existing GitOps workflows. So I'll make this more concrete with a couple of demos. And in the first demo, I'll show how Radius can be used to deploy applications unchanged. First, we'll go across on-premise and AWS. What you'll see is on-premise, the application deploys and leverages a Redis cache on a Kubernetes cluster, and AWS, a recipe automatically deploys MemoryDB in the AWS environment. So we'll walk through that. And you'll see me running the demo through the Radius CLI, but obviously in a production environment, those would be GitOps workflows. So let's kick this off. So I've already set up a Radius control plane on premise and in AWS. And you see I have 2 workspaces, one for each of the environments. And as I mentioned, Radius, sorry about that. Radius, let me start that over. So Radius knows how to deploy resources using recipes. And what you'll see here is on-premise, I have a bicep recipe. And that's going to deploy Redis to a Kubernetes cache, or a Kubernetes cluster, excuse me. And then on AWS, I've got a Terraform recipe that will deploy the MemoryDB. And so I'll put on my developer hat and actually go look at the application definition, and you'll see the application's simple. It's got a front-end container and a Redis cache, and those are both native resources supported in Radius. The front-end container has an image, a port, and then this really powerful feature that is a connection. Connections enable Radius to do a lot of work behind the scenes for the developer, including making those explicit connections that show up in the application graph, but also injecting details like connection strings and credentials into the container as environment variables. And that tells the container how to connect to Redis no matter where Redis is deployed. So back in the terminal, we'll run rad run deploy, or rad run the app, and that's going to deploy the app and give us a port forward so we can actually see the application working. And you can see the deployments in progress. The cache is deployed, the front end is deploying. Okay, so the app's running now, and we'll navigate to the port forward to localhost 3000. And when the app opens, we'll be in a container info tab. And that's going to show me all the environment variables that Radius automatically created in the context of that connection that we were just talking about. Then we can click on the to-do list tab and just see the application actually working, right? So we're going to enter a to-do item, integrate Radius into your IDP. Everybody should have that on their to-do list. And then it's just basic functionality, right? I can complete the task and delete the task, and so just so you see that the application's up and running. Then we'll look at this Radius dashboard, which is cool. This is a backstage-based UI that allows you to see everything that's in your Radius environment, your applications, the recipes that you're using to deploy the app, and then this GUI a representation of the application graph that I mentioned. Now, this is a super simple graph, right? It's just 2 nodes, but you see that explicit connection between the cache we deployed and the front-end container that we deployed. In a more complex application, that's when you really see the power of the graph. If you think about multiple team members working on a big, complicated application, seeing it represented in this way is super helpful. So that was the local deployment that we were just checking out. Now let's deploy to AWS. We'll deploy it to AWS using the terminal on the left, and then on the right, we'll redeploy to that local environment. We're going to use rad deploy command here, and that just doesn't give us the port forward, but we'll look at the application graph in the context of the CLI this time, because I want you to see the comparison of what gets deployed on AWS on the left and what gets deployed locally on the right. So the deployment's done. We're going to run rad app graph. And what you'll notice with AWS on the left, local on the right, the front end configuration or deployment is the same on both sides. What's different is the infrastructure that got deployed. So you can see in the bottom left-hand pane, AWS specific resources, MemoryDB, cluster, and subnet group, for example. On the right is just the Kubernetes resources for running Redis locally. So that shows you, hopefully, how easy it is to use Radius to separate applications from the infrastructure that's deployed to enable those applications. Okay, so that's one quick demo. And what we saw in that demo, remember there was a container resource and a Redis cache. Those are native resources that are supported by Radius. And those are helpful. They get you up and running. There's also databases, message queues, and the like supported in the box with Radius. But what platform engineering teams really need is the ability to create custom application resources and catalogs for those resources. And that kind of custom resource enables platform teams to build really customized developer experiences. And custom application resource catalogs with browsable integrated documentation, and modeled sort of any type of resource. It could be abstract like a web service or something really concrete like a document DB. And the custom resources function really as a contract between the developers that are consuming these things and the platform that's providing them. So the next quick demo shows how we create a custom Radius resource and use it to add a new feature to the same to-do app that we've been showing. And obviously it's 2025, so our demo app has to have AI. So that's what we'll add, the feature we'll add using a custom resource. So what I'll show is how to extend Radius using this custom OpenAI resource, how to define it and then deploy it with a recipe, and then as a developer, how I would use that resource in the application. So here's the same to-do list application. And you see there's a feedback button beside the add button now. And so we ask Copilot for feedback, but it fails, right? Because we haven't added that support yet. So the first step is to create a new resource type definition, and it's called OpenAPI, or OpenAI, excuse me. mycompany.app is the namespace. And then we have some boilerplate code, plus a capacity property. This is where I define that all my developers have to indicate as a t-shirt sizing of a small, medium, or large, which is their preference for interacting with a custom resource like this. So now that we have the definition in that file, we're just going to upload that file to let Radius know that this new resource exists. So we'll use the resource type create command here. And it just takes that file that we were just editing and uploads it to Radius. And that basically extends the Radius API so it knows about this new resource and supports it just like a native resource that we saw in the earlier demo. So then we'll register a recipe for this OpenAI resource, just like we used recipes in the previous demo. And I've got a template that deploys a GPT Turbo model using Azure OpenAI, and we'll use that template. So there's the recipe. So we go back into the app now. So again, with the developer's hat on, we'll add this resource to the application, and you can see VS Code and Copilot now understand this resource, right? It's treated as a first-class citizen by the developer tooling experience. And it's prompting us for all the required properties that were defined in that resource file. Now the capacity was not required, so the developer's adding that capacity value now, and they get a nice tooltip, right, that says you can choose a t-shirt size for that resource. So capacity set, the last thing is we saw before, right, we add a connection. We add a connection between this container and the new AI resource, so we get the Copilot integration that we're looking for in that front-end container. So we'll do rad run again, just like we did in the previous demo. It's going to give us that port forward. We'll go see the new application installed. This is running on Azure, so Radius will create the model using Azure OpenAI, right? It's Azure-specific infrastructure for this deployment. The cache will be Azure Cache for Redis. The front-end container gets deployed on a Kubernetes cluster. Radius creates a service account, exposes that service. Then here back in the UI on the container info, we see that new resource. We see the environment variables that were injected based on the creation of that connection. Then we can go into the app and test that Copilot integration. So again, we're integrating Radius in the IDP. Everybody put that on your list. We'll ask for feedback. This is funny to me. Copilot says, we've got a complex task ahead. We're finding it's pretty easy to integrate Radius, so I think there's some model training that would benefit. Copilot, but you see how easy it is to use Radius, both to deploy across different environments and to extend it for use in a custom IDP. Thanks, man.
Cool stuff, right? As you see on the bottom right, our story didn't start with Radius. We have a lot more boxes there on that diagram. So our story starts in 2021. We started a program that we ambitiously called from 8 days to 8 minutes. The idea was all of the build and deploy to all environments of a microservice shouldn't take more than 8 minutes. And the driver there was really accelerating service delivery. We needed to push away from this guy's building some infra resource for that guy to deploy the app. But still, we needed to respect the fact that those are two different life cycles. And not only that, we wanted to, well, it was ambitious, and it is ambitious. We wanted to cover not only infra stuff, but the whole IT lifecycle. So registering the app in the CMDB, for instance, and all of the stuff you can imagine we as a regulated industry company need to do for everything we run. But again, given that time and money have limitations, we did not want to reinvent the wheel. We did not want to say to people, tomorrow you'll use this brand new thing. Good luck. And we had stuff in place, like we had and still have a big Terraform module library. Everything is Terraform, or was. So, the most important delivery we identified at the time was, sure, we know how to do infrastructure as code. We know there are many tool sets to do continuous compliance, drift reconciliation, all of the typical IT resource lifecycle management things. What we're missing is application as a first-class entity, application as an API. And because we all know how software development should kind of work, we know versioning, we know deployment patterns, we know all of that stuff. We wanted to do the same for infra. So, back in 21, this was what we started building. I want to do a new microservice for my business demand. Sure, you've got templates on a web UI. You pick a template to fill out the name of the thing, the business domain it's going to run under, topology, technology dependencies. Yeah, it's going to need cache. It's going to need a relational database. It's going to do messaging, whatever. And besides all of the cool stuff, we give the development team automatically, when this is filled out, repos, pipelines, security stuff, all of that. We captured that in a file, JSON. Everything and everyone knows JSON. This file, which sits on the code repo for the app, is editable anytime by the developers, says, these are my app details. My app can be exposed to the internet. It has these operations. Optionally, you can put SLOs under each one of those operations. You have messaging details, schemas, the app roles. It has an admin role. It has a reader role. It has, you name it. Does it need Redis cache, persistency details, whatever? It's in JSON. Why? Because after we have that file, back in 21, we would convert a part of that to Open Application Model definition, OAM, and pass it along to GitOps, Flux, Kavela, and infrastructure as code toolsets. And we were almost there. Still, the gap was enough for us to get together and do a lot of whiteboarding
Yeah.
for almost 3 years.
Yeah.
And say, okay, now we know the gap. We need to cover the gap between this design and this one. And basically the gap is what Jonathan was showing. That sort of user experience and user-defined types as easily as you saw today that needed to be brought into this model. So today, what we're doing is bringing people over. I've shown you an old JSON file. Now this is what we're trying to do. Sure, we have a CLI that converts JSON to YAML. You, by the way, did not see YAML on the previous demos. You saw Bicep, right? And some people may think, oh yeah, Bicep, another Microsoft format. We do YAML. Same thing. And if you look at it, it's a standard Kubernetes CRD. It's called deployment template. And this deployment template is just picking up the parameters for the recipe. In this case, this is just a React.js basic app. So the parameters are things like it's an extra small app, image repo is over there, it does observability with Prometheus and a couple of other things. And that bit, so line 29, the template, is the JSON representation of the Bicep. You saw earlier, the same sort of thing. For those of you that are kind of familiar with Azure, you might recognize this as an ARM template with extensions. Now it's importing the radius. And this file, YAML file, GitOps process, and so on, does what you just saw in the demo. Spins infrastructure up, wires it to the app, well, and things run. So, if you're a developer on your local machine, you just register the version of the static front-end recipe that runs it locally. Even if you're calling out to OpenAI, the radius control plane is local to you, so you run it locally. If you're deploying it to shared infra, sure. Use a recipe that takes advantage of that shared infra, crossplane, Terraform, all of that. However, you use it. So if you do kubectl on a pipeline, if you use GitOps, if you use customize to specify values for each environment, if you have a Helm chart for your app, just drop the deployment template into the Helm chart, you version infrastructure as part of the application. That's the deliverable. So, where's the box? It's just another CRD. But you get the infra for that version of your app. What we've learned so far from this, enable the right conversations. You no longer talk about, do I have the database schema that I need for this version of the app? You talk about feature testing, progressive rollout, and all of that stuff you should be talking about, my opinion. And you look at best of breed implementations. So you have 5 teams doing, this is how I spin up my databases. Pick one and get everyone on that pattern. Put that pattern to your recipe. And because everyone's doing it the same way, with as much knobs as you want them to have, predefine SKUs, predefine SLAs, and independent lifecycles. So infra guys know what they need to support. It's in the SLA, it's in the contracts. Devs, I just want a medium-sized cache. You know what the throughput, memory size, all of that needs to be? No, do whatever you want with that information, but do it the right way. And we all know how to do it for apps. do it for infra. Solve the right problems with the knowledge that you have for the app definitions. Push infra aligned with the same maturity that you have to push code. That's what we've been trying to do, and that's what we're doing more and more. You want to wrap it up?
Sure. Thanks, man. Thanks, everybody, for the time. So one of the key kind of messages that Nuno and I wanted to share is that we see this application model, kind of capabilities that Radius brings to the open source community as a general purpose requirement for most IDPs, if not all IDPs. So it's a plea to join the community. We've seen a lot of companies go out and kind of roll their own type of abstraction similar to Radius in a lot of ways. We can avoid a lot of redundancy and get a lot of value out of collaborating together. So you can get to the Radius documentation from this QR code. That also has links to our GitHub, to our community activity, information about monthly community calls. So please join us. If you have questions, reach out on Discord. We got a very active support channel, and we'd love to see more folks from this room involved. So thanks, everybody, for the time. Thanks, Nuno.
Thank you.